This problem looked really hard, so I thought we would give it a try. Maybe it's not as bad as it looks, but you have two carts that are moving in the same direction, and they're connected by a pulley. And cart A pulls cart B this direction, and of course it actually moves horizontally. And they're going to ask us some questions about it. They give us some information and they say, two carts are connected by a rope that's 39 feet long. They pass over a pulley. The pulley's 12 feet off the ground, and cart A is being pulled away. How fast is cart B moving? So what would be the best way to go through this? It seems to me that what they're giving us is two triangles like this. I'm going to call this A and B for the cart that they're actually pulling. But then we have the hypotenuses, because we know this is 12 here for both. So I'm just going to call those C and D. Because why not? And we know C plus D equals 39. That's nice. It's not that useful at the moment. But I did notice that cart A is 5 feet from Q. And I don't know if you know your special triangles, but that's 5, 12. This is going to be a 13. And if not, you can do the Pythagorean theorem and find that for yourself. And from 13 out of 39 total, that leaves me with, 26 over here? And we could probably find this length if we need it. Let me pull my calculator machine out and see if it comes out to a nice number. It does not. So we'll call this the square root of 532, just to keep it clean. So at least we know these values to start. Now that's nice. But they're not asking for these values. They're asking how fast is cart B moving towards point Q here in the middle. How fast is it going this way? Okay, let's find a way to do that math, shall we? We know that A squared plus 144 equals C squared. And we know that B squared plus 144 equals D squared. Of course, we found these actual values, but the bottom bases, A and B, are going to change in size depending on where in the problem we are. They gave us some specifics, but we want to write the general equation out to find the derivatives. So I'm going to go with this. And they're asking us to find how fast B is moving, so let's just remember that's going to be like dB dt or something like that. Okay, so what am I at here? I think we could find that C is the square root of this. We could say that C equals A squared plus 144 to the 1/2. We could say that D equals B squared plus 144 to the 1/2. And then since we want a dt, we'll take the derivatives with respect to t. And I could even say that these added together, maybe I can just copy and paste this one. Could we do that? Would it be faster than just writing it again? I don't know if it would. My computer is pretty slow. Plus this guy. It'll look cool though, because it'll look exactly the same somehow. B squared. That's going to equal 39, the length of the rope itself. That's this plus this. I'm sure you guys get that. Then from here, I think we're going to have to take a derivative. I don't see any way to make it cleaner. So let's do the power rule. I'm going to get a 1/2 A squared plus 144 to the negative 1/2 times 2a I think that's what it's going to look like, plus 1/2 b squared plus 144 to the negative 1/2, chain rule, 2b equals 0. We cross these off, the 1/2 and the 2's, so that's nice. And we're going to get a over the square root of a squared plus 144 plus b over the square root of b squared plus 144 equals 0. And the only thing that I left out here, the most important part, is the dt's, because this would be dA dt, and this would be dB dt. Don't miss your chain rule on that. So I'll put that right here. I was so busy trying to get everything formalized up in a nice looking way that I didn't put in the chain rule part. But I've remedied that now. So first things first, we are looking for dB dt. So I think we might just go ahead and migrate this ugliness over like this. Can I do it this way? Let's try it again. I might get used to doing it this way. Subtract it over to this side, and watch me put a minus on it. Oh, that's nice. That felt good. I'm not going to lie to you. Let's multiply this part to the other side by inverse. So that would be the square root of b squared plus 144 over b. And we'll just scratch all that out. We should have our dB dt if we can fill this nightmare in. So I think we actually know these values for this particular instance because we calculated them here. So let's fill them in. A is 5. So we could do -5. And what is dA dt? They told us that in the problem, right? Okay, here it is. It's moving at 2 feet per second. It's moving at 2 feet per second. Divided by a squared. A is 5, so a squared is 25, plus 144 is 169. The square root of that is 13. Times b squared. Well, what's b? That's the square root of 532. So b squared is just 532. And 532 plus 144 is 676. So that square root is going to be 26. And by the way, you might notice that's the same as this length here that we calculated, right? That's the length of d. That's what this represents. Divided by b itself, which is not a good number. Was that the square root of 532? That's what it was. Okay, so we should, for dB dt, be getting close. That's -10 on top, so that'd be -260 over 13 root 532. 260 over 13, I think, is 20. Let's double check that. It is, so that would be -20 over root 532. Let's figure out what that is. I should warn you, I'm putting it into an actual calculator. So the answer I got here is 0.8671 negative for dB dt. And that's the right answer. So what I found here, using some shorthand decimal work, is that you want to create a generalized equation for a squared plus b squared equals c squared. So even though you could calculate all these values out, in order to get a useful derivative, you need to come down here and write out the actual formulae and take the derivative from there. And then no matter how ugly it is, and I assure you we all must agree this is kind of ugly, this is what you're going to want to put in. And then you're going to come up with the right answer. You know what I'm saying? Yes, I believe I know what you were saying.